Yeah, good to go. Calgary, can you let me know if you can hear and or see me okay? Thanks, Peter. Okay, let me check on the video. Sorry, I'm talking to Calgary now. You guys, you can ignore me. Um, Calgary, are you good now? Right. Awesome. Thank you, Peter. 2 seconds. Okay. How's everyone doing? Good? Calgary, how are we doing? How's week 3 treating you? Tweeter? CSS. Was that enthusiasm I sensed? No. Okay, so Calgary, we're getting some not enthusiasm from Vancouver about CSS. Awesome, cool. Well, that's good because I'm not teaching you about CSS today, so I feel pretty happy about that, knowing your feelings on it. Can I have a volunteer from Vancouver to keep an eye on the Calgary Slack channel? Peter, I'm looking at you because you did it last time. Awesome, thank you. You do it once and then you just have to do it every other time. That's what you get for being a good person. Christian, Ajax and you are not friends right now. That's okay. The best of friends start off not being friends, and like by the end of this, you're gonna be tight. Chaining requests, angry face. Oh, yeah, I feel you. Yeah, that sucks. I guess we're gonna do a bit of that. We're not really gonna do Ajax today. So all the stuff that you're not enjoying is fine. I'm just gonna introduce you to something else that's gonna frustrate you maybe. And that's boot camp, if you haven't picked up on that already. Cool, so today's kind of a big day because today you officially become full stack developers. Dun, dun, dun. So you're good now. Like you can go off and get jobs. It's fine. You're done after today. You're now employable as a full stack developer. So what makes a full stack developer? Well, we've got front end, I'm going to open up my Markdown preview. Oh, I don't get the checkboxes. No, wait, I do. There we go. We've got front end, and we've done front end, right? That's what we've been doing this week is Tweeter. When working with HTML, CSS, and client-side JavaScript, all the Ajax stuff. It's front end. And then you've got back end. And have we done back end? Mostly, yeah. So Tiny App, we did CRUD. We wrote the create, read, update, and delete routes of the back end. We wrote the code that handles the application and logic. What we haven't done is database stuff. And when I say database, I'm particularly talking about state management and persistence. So today, just check on Calgary, we're going to be looking at, we'll spend the first kind of section motivating the idea behind this data persistence, state management. And then we'll dive into doing some coding. We'll look at a bit of I want to say theory. It's not really theory. It's more like, why is this a thing? We're going to be working with MongoDB. And this is one of two database management systems that you're going to be working with over the course of bootcamp. More if you decide to look at others for your final project. But we're going to start with MongoDB, and then the next one you can worry about next week. So we're going to talk about everyone's favorite project today, Tiny App. You thought it was over, and it's not. We're just going to talk about Tiny App. We're just going to revisit that a little bit. We're going to look at the things that we can do with Tiny App, and then the things that we can't do with Tiny App, and see how we can kind of cover those holes. So the things that we can do with Tiny App, what can we do? Well, we've got the CRUD stuff, right? We can create a tiny URL. We can look at or read a tiny URL. We can update or edit. And we can delete or destroy a tiny URL. We can also, we can create a user, and we can log in as a user. This is kind of this is all CRUD stuff, this create, read, update, delete, and this is like a non-CRUD kind of thing. But it's still something we can do. Still something that's handled by our backend or our application logic. So let's start with just how do you get Tiny App to run on your computer? So Calgary, how do you get Tiny App to run on your computer? In the beginning, because it doesn't come installed, right? Christian's typing. Localhost. Yeah, we run it through localhost. npm start, awesome, thank you. Yeah, we go npm start, and that runs our server on localhost and whatever port we've specified. This is the kind of thing, so when I say what do you get up and running, this is what kind of things do you put in your README for your course evaluator to be able to get this up and running? We run npm start or npm run start, whatever that command is. And that runs our server. So in order to use Tiny App, there has to be a server running. It has to have the server running and listening to incoming requests. So requests to create, to read, to update, and to delete, and/or delete. Now, what happens, and you will have encountered this in TinyApp, what happens when I run my server, I create a bunch of tiny URLs, and then I stop my server? They're gone. Everything disappears, apart from like anything I've hard coded. So in TinyApp, we had our URLs database, which we've stored in the top of our file as a variable. So that still lives on because it's hard coded in, but anything that you've made on the server disappears. So that's like technically okay, I guess. Maybe we could just run TinyApp forever. Like maybe we could just run the server forever. But I know that you all are a little bit more technically inclined than the average person. What do you think the likelihood of a server running forever is? Yeah, like none. Like that's not gonna happen. So let's dive into like a little imaginary scenario here. Bear with me. So you've made TinyApp. You've finished all the features. You've added some testing to it. You've got a super like trendily designed homepage. It looks really good. Everything works really well. You've got like everything you want in there. And we want to release TinyApp to the public. So we want to put it on like the best server ever. So we get like a super, super good server to put it on. You call up like NASA or something and you pay them a bunch of money and some like subscription per month for the privilege of running on their computer. And you get a domain, you have a nice URL that people can go to, and because localhost isn't going to work, right? Because that's just on your computer. So you get into the supercomputer and you run npm start. Great. So you've got your URL and you start sending it out to all your friends. And they're like, whoa, I've never seen this before. This is amazing. I can create like little URLs. Awesome. And they get really hooked on it and they start sending it to all their friends. And then lots of people start using your TinyApp and it becomes like an internet sensation. And it goes worldwide. And pretty soon you've got the whole world using your TinyApp, right? This is what happens after boot camp, in case you didn't know. So you're basking in the glory of your TinyApp success on your like private beach. And you start thinking like, you know what'd be cool is if I could have like, have a report of everyone that's logged in or registered this month. Or if I could like see all of the links that link to Google. I want to like see that. Or maybe I want to add in like a cartoon owl that runs across the screen for fun. Right? Can you do that? TinyApp 2. You can do that, but you have to stop your server. And then what happens? You lose everything. You lose your private beach. I mean, you would eventually because your users would not be happy with you. So yeah, like everything meaning, thank you, Greg. Yes, the data does not persist. If only we could store it somewhere. You're like 5 steps ahead of me, man. I've still got a lot to go in this TinyApp analogy. You lose everything. Thanos and his evil twin have shown up and just obliterated all of it. So what do you do? Okay, now, Greg, now it's your cue. We want to store the data somewhere. We want to keep it persistent. We don't want to lose it. That's important data. Like applications are run off of data. That's how people make money, is data. And we want a way of being able to shut off our machines without losing that data. So is everyone kind of understanding why we need to be able to store data? That like we're happy with that. We want to store our data. Yeah. Not our passwords, but our data. Everything apart from the passwords. Print out all data every day. Yeah, so that's something you could do. If you really wanted, you could grab yourself a little notebook And every day you could go through TinyApp and you could just write out all the logs of everyone that has made like a request to create a TinyApp. You could just have like, it would look like an Excel spreadsheet, but it would be handwritten. That's technically a database, but I'm guessing you're not taking boot camp because you want to spend the rest of your life writing in a notebook. Maybe you do, and if you do, that's awesome. Or we could print it out. We could like just get a huge file cabinet and print out all our data. And then when we want to find something, we could just pay like 5 of our friends to have to go through this data for us and dig and search for like, oh no, it was April 2019. Like which folder? There's 10. So yeah, so we don't want to do that. We want to store it somewhere. So let's talk about how TinyApp currently stores data. Because it does in a sense. It stores data in memory. And what this means is that, as we know, when this particular instance of your server is shut down, the in-memory data goes with it to like server grave. So in TinyApp, now, we did store a bit of information in cookies, but that's not our database. That's just like passing little bits of information. So that's when we're talking about storage of data, cookies aren't really a solution to that. But how did we store it? We stored it in an object. We stored it as a variable at the top of our file, and then when we got a new request, we added that to this object. So it's just a JavaScript object. And we would describe this. So with the exception of our hard-coded data, as soon as we lose the data, we would describe this as being not persistent. This is a non-persistent way of storing data. We want our data to persist. We want our data to be available no matter what we do with our servers. And this is where really the third kind of section of full stack comes into play. So when we talk about, let's go back to front end. When we talk about front end, what do we have? We have CSS. Back up. We have HTML. We've got our client-side JavaScript. Got Ajax. jQuery. Like Flexbox. Fancy design thingies. Basically anything that has to do with user experience, user interface kind of things. That's our front end. When we talk about back end, we have, I guess it's the ability to serve like specific pages and responses based on data that you get in, based on different routes, really. So and when we're talking about different routes, like we've got, let's say, get robots. And then also based on certain parameters. So like, who's logged in? Now what the backend also should do is store and manage the data. And these are the things that make your server useful. So, for example, like if tomorrow Facebook lost all of its front-end code, like their entire front-end stuff was just toasted, they'd be fine. They have all of their data stored, and that's all they need. They own all of our data anyway, and they have that stored, and so all it would be is just like paying their developers overtime to recreate the front end. But the value really lies in the data. So I guess most useful web services that we use are just interfaces for storing and managing data. That's really what they're doing. So for example, like YouTube, all we're doing is like storing videos, showing videos, maybe like storing comments. Same with like Wikipedia. We're like storing articles, we can edit them, but all of that is just data. Calgary, how we doing? Good? So bearing that in mind with all of these services, we're looking at how we add data, show data, edit data, and delete data. And this should be looking familiar because this is very closely tied with our CRUD actions, right? We're basically talking about CRUD here. So so if having the data stored inside the server means that we lose the data every time we shut the server down, we should be storing it somewhere else, perhaps. And don't store your data in the servers, because then you won't lose it. And there's a few different ways of doing this, but let's talk about some like qualifications of storing data, and storing it nicely. So we're going to look at what we want when we're storing data. So what do we want? First of all, I want the data to persist. I want to have some smart interactions with the data. And when I say smart interactions, I mean like asking questions. I mean like, hey, give me a report or a number of how many users logged in this month. Or give me all the information that you have on this particular user. So that's what I mean when I say like smart interactions. And then I want multiple applications to share the same source of data. And these are kind of like my 3 ideals of having our data stored. So so like smart interactions. How many of this thing do you have? Or find me this particular thing and its associated data. And what we have in order to be able to do this, a database. A database is just basically a separate thing that your server talks to that holds your data. It's a container. And when I say thing, I mean it could be anything. It could be that notebook that we talked about. It could be a file folder of 1 million printouts. That is technically a database. It's just a thing that contains the information from your server. If we think about this as kind of like a 3-tiered model, what we've got is an interface. This is our front end. This is what the user is interacting with. We have our application. And along with that, we have the logic. And this is our server. And then we have our data. Interface, application, and logic, and data. The front end, the place that we make a request through a form, maybe. We have the application and logic where we do something with that request. We parse it. We then maybe ask the database for something. So a user uses the interface to interact with the application, and then which then manipulates the data. So we got like pretty stuff, logic like user does not exist. And then we've got everything we need. So some other ways of storing data, and we're going to make our way slowly to the actual database systems that we'll be using, but let's just look at some other ways that we could potentially store data. We could write to a text file. So we could write to like a CSV, a comma separated values file, which if you've worked with Excel before is what you would get if you download as like a CSV and then you can upload it. It's commonly used with Excel. It would look like let's say name, job title, favorite dog. And then on the next line, you would have like Sadie, developer, German Shepherd. And then maybe we've got Benjamin, who is a morgue attendant. And his favorite dog is a Chihuahua. And this is what a CSV would look like. Which is fine. That is one way of storing data. We could also have it in a JSON text file, and that gives us a little bit more flexibility when we're working with our data. So that would look like a JSON object. And let's say we have an array, and we've got name, job title, favorite dog, and then let's say he's got some skills because we want to nest some data, and we could say he likes knitting, and we'll give him like a 7 score for knitting. Baking, a 4, and organ identification, because he's good at his job. We'll give him like a 10. That's a 10. He was made to be a morgue attendant. So get some indentation going. This gives us a little bit more flexibility over something like a CSV because we're now able to have nested objects, and that's something we can't really do with that like strict file structure of just, no, you've got columns, which are these like in rows, and fields basically. So when we write to a text file, we can do it in different formats. And this is nice because it gives us a bit of flexibility. The cool thing about a text file is that we can store it somewhere. We could upload it to like the cloud and then grab it whenever we need to and like download it into our application. We're going to be doing something kind of similar to this. But instead of storing in a text file, we're going to use a separate program that we're going to talk to, and the program is going to store our data for us in a JSON format, which is pretty handy. So the program, the program itself is a database management system. And the one that we're going to use this week, as we've talked about, is MongoDB. This is what you'll be using this week. You are going to be using something different next week, and they both work in quite different ways, so it's good to see how those work. But today we're just focusing on MongoDB. This is what you'll be using for Tweeter before you get introduced to the other one. So the way that Mongo works is that it's essentially a place to store a bunch of JSON. So in the example of this up here, we could just dump this into Mongo and it would persist. The data would persist. Some other database systems, just because you'll be working with Postgres next week. Some other ones that you might hear are MySQL, MariaDB, CouchDB, Oracle, Mongo is a little bit different from these ones in that it is a NoSQL database. And that's something that I'm not really going to expand more on because you're going to learn more about it next week. And this will put this concept into more context next week when you start working with Postgres. But essentially what's important to know is that Mongo stores JSON. So what we'll do is dive into reading up a little bit on Mongo. We will do a couple we'll look at how the Mongo shell works, see a bit of it in action, and then take a break. And after the break, we'll do a bit of a bigger demo in the context of an app like TinyApp. So Calgary, you good? How's it going? Dan's typing. Swell. Awesome. Thanks, Dan. Okay, so I'm going to start off by just hopping into my terminal. And I'm going to show you, I'm in the Mongo shell right now. I'm not going to show you how I get into Mongo because it is basically just writing the Mongo command. It looks a little bit differently because I'm not on Vagrant. I did have a connection to Vagrant. It's because I woke up this morning and checked out Mongo and it crashed and I had to uninstall it and reinstall it. And now I'm a little scared to close out of it because I'm terrified it's not going to work. I'm sure it will. I'm just a bit superstitious. So Mongo comes loaded up on your Vagrant machine. So you shouldn't have to do any installation for it whatsoever. You should just be able to go and type Mongo into your terminal. It works? Yes. Awesome. And you'll be connected to the Mongo shell, which is awesome. So I connect with Mongo and I get my Mongo shell version and connecting to test. And then what I've done here is write, and I'll just do this again, show DBS. This shows me the databases that I've currently got in my Mongo shell. Yeah, and this little pointy bracket means that I'm in the shell, so I know I can type Mongo commands. Mongo is built up of two parts. So we've got the database that has to be running somewhere, and then we've got the program that we use or interface with to interact with Mongo. So MongoDB is a separate program running on your machine that you can just throw things into. When I run the Mongo command, I get entered into the Mongo shell and I can use that to talk to Mongo. Say hello. No, it hates that. Hello is not defined. It does say bye to you when you exit out of it, which is nice, but it won't say hi back. I can do other things I can quit, but I'm not going to quit. If I wanted to quit, I would write quit as a function like that. And this should look kind of familiar to like Node. So when we're working with the Node REPL or the Node REPL, this is what it looks like. This is our like interface. The language that we're going to use to talk to Mongo in this shell is going to feel pretty similar to JavaScript. The syntax should feel pretty familiar. So now, before we get ahead of ourselves, what's the first thing that you think we should do before using a new technology? Run help? It's not a bad idea. I wonder what help. Yeah, that's a really good idea. That was not what I had in mind, but that's a great idea. Run help. Yeah, see what you've got access to. Awesome. I've got exit. I've got db.help. This is good. This is a nice snapshot of some things that we can do with Mongo, but I want a little bit more information. Where do I go? The documentation. Yes. We're going to go to the docs. We're going to hop on over to the MongoDB docs and have a look before we start writing code just yet. And the first thing you should do when you're working with Mongo is go ahead and bookmark these documentations. I preach this to read the documentation. I'm really bad at taking my own advice. I was working on a project a couple weeks ago, and I like just copied and pasted some code in because it looked like it was going to do what I wanted it to do. And I spent a good little while getting really frustrated and being like, why isn't it working? It's not doing the thing I want it to do. And then finally I was like, oh, I guess maybe I should look at the documentation. And I go over, and sure enough, like right in front of me, there's instructions for how to get it to do what I want it to do. And I learned my lesson for like the 100th time. So when you're stuck on something, and it's not like, when we say read the docs, I'm not like, don't go and sit down with them like a book and read the whole thing. If you can do that, that's amazing. But it's not really realistic, right? Use the documentation as, oh, I need to do something really specific. I need to go and look up that as a reference and see how this is done in this particular program. So not all documentation is created equal. There are some bad docs out there, but the MongoDB ones are really good. And actually, I want to point out something really quick. So this is our MongoDB shell docs. This is the MongoDB Node.js driver docs. Are these the same page? No, they're different. So we actually have two different documentation, like pieces of documentation. The MongoDB docs here are going to be for interacting with the shell in particular. So when we're running in the terminal and we're operating those commands, these are the documentation. This is the documentation we're going to be using. When we get to implementing Mongo commands in our app, in our Node.js app, that's when we're going to switch over to the MongoDB Node.js driver. So if you find you're looking for something and can't find it, just think about, like, what am I looking for? Am I using the shell to access something, or am I in my application? So the MongoDB docs. Okay, getting started. Got some prerequisites, that's fine. We've already installed MongoDB, so we don't need to worry about any installation. And the first thing I get is insert documents. This shows me a bunch of different actions that I can do. So insert, query, we've got some next steps, we've got a find, and these are all different actions that we can use within our shell to interact with our data. So the Mongo is structured kind of like this. We've got the server, which is the Mongo server program. Inside of that, we can have many databases. And inside of those databases, we have things called collections. And then within the collections, we have documents. And the documents are going to look like the JSON that we just looked at. So every database is built up of many collections. Every collection has documents. And so what does that mean? Like, let's think of it in a real life example. I might have a warehouse. And inside the warehouse, I have an office. And inside the office, I've got folders. And then, like, within those folders, I have papers. So the kind of architecture here is server, databases, collections, and then documents. So I've already connected to my server. I've got this one out of the way. I've typed in Mongo and I'm connected to my server effectively. If I wanted to see all of my databases, I could type in show DBS. And I get, so we're going to be working with NASA today because I got some JSON from like how many people are currently in space. I would suggest asking Nima about his hip hop database because he has an extensive hip hop database, and he will get really excited to show you it. I'm really sorry to disappoint anyone that thought we were going to be using hip hop. We're talking about NASA. If I want to use a particular database, I can say use NASA, and I've switched to the NASA database. Is this big enough for Calgary? Is the font text size okay for you guys? Just wait for Greg and Dan. Could it be? Yeah, sure. How many entries in the hip hop database? Font's fine. There's a lot. 50,000 songs, Calgary. Yeah, so 50,000 songs, and Nima built it. So we'll do a little bit bigger. Calgary, let me know if that's all good. Yeah, like I have data in here. It's just like 6 entries. So it doesn't look that big, whereas there's a lot of hip hop data. Cool. So now what I can do, now that I've switched to the NASA database, I can run queries on this database. So I could run show collections. And I get my collections. And in this instance, I have a collection of people. So this is a collection of all the people that are currently in space right now. And so we have a server. The server has the NASA database. The NASA database has a collection, which is the people in space. And and this contains the people in space and then the current, I had another one that showed the current location of the International Space Station. Now, once I've said I'm using a particular database, from the shell to query a collection, what I can do is write db.people, so the name of the collection, and we can go find one. Didn't work. That's because I needed to chain it. So Calgary, I'm with you on chaining. There we go, find one. And what I get is a JSON object with an ID, a craft, so where they are, and then the name. So Oleg is on the International Space Station right now, currently. And this is one of the really nice things about Mongo, which is you think Nima likes hip hop, Silicon Valley. I love it. Yeah, so the really nice thing about Mongo, which is kind of different from other databases, is that you can just store JSON in MongoDB. You'll find when you're using different databases, you will have to like manipulate your data a bit more in order to be able to store it. And that comes with pros and cons. There's good excuses or good reasons to use both. Mongo is really quick. You just shove some data in it, but the data that you get back out might be a little bit more like performant when using other database types. So there's some other methods we can use. And actually, let's use hip hop. And show collections. We've got artists, lyrics, and songs. And for this one, let's say db.songs.count. So there we go. Which was, yeah, that's how many you've got. Now we can also, we can get like more of these commands. These are just some of the common ones that we would use. We can get more of these from the documentation. So first thing I see actually is the insert docs. So I get db.collection.insert many, and this will allow me to insert many documents. And as you can see, it's just a chunk of JSON shoved in, right? We can use find, and we can use find with an argument. So let's say if we swap back into NASA and show collections just to see what we've got, which is the people. I want to db.people, which is our collection name, .find. And I want to filter that. I want to query by, we're just going to do craft equals the ISS. And there we go. I've got a filter which prints out all the people that are currently in the International Space Station. Now, this happens to be all of them because apparently those are the only people up in space right now. But that's how I could filter something, is by using this argument within my find method. When I use find one, I'm just getting back like the first object in that collection. It's like formatted nicely for me, which is cool. But basically anything that you want to do with CRUD actions, you can do with your Mongo shell. Let's say, actually, so there's the documentation. There is also there's a guide. Yeah, this is within the docs, but it's just easier to Google it. And this is nice because you actually get a shell that you can practice with. So if you're like looking for a command and you want to practice, so if I want to insert something, I've got this db.inventory.insert one. And so let's just say I copy this and I paste it in. and I get this little message back saying, acknowledged, true, insert ID. And so Mongo will automatically like generate this ID. And it comes in this funny like object ID, which we will account for later when we're putting this into our app. So I've inserted, but I didn't actually have the inventory collection before I inserted this. Like that didn't exist in my database, but Mongo just goes like, oh, you want a collection of inventory? Cool, I'll create it and then I'll insert this in. And so now I can go db.inventory.find and I get back the object that I've just put into it. So it did a little extra work where it created the actual collection for me. I can run show collections and I get back inventory. So we're literally just passing it a JSON object to be inserted into the collection. Mongo just doesn't really care what you want to insert. It just goes, it's JSON, cool. With the structure of my space station, what I could do to insert one is write db.people.insert1. So we've got insert one and insert many, and those act as you would probably expect them to. Let's say, go name and craft at the Lighthouse Labs craft. Cool, so I've got acknowledged true and I've got my ID back. So it's with every query, it's sending me back a message to say, yep, it worked and here's your new ID. And now if I run db.people.find, I get my new object. It's in a different order because it's just like the order that I put it in. Ooh. But in terms of the object itself, it doesn't matter what order that's in. It's still recognizing that the craft is Lighthouse Labs and name is Sadie. So when I'm interacting with this as a JSON object, it will still recognize like the names and the crafts. And now I have an extra entry. So, oh no, it said I exited out. Okay, so that's what happens when you exit out. You get bye. So we're just gonna go, okay, it worked. I didn't need to be superstitious. Yeah, Peter. Yeah, so this ID is created by Mongo when you insert it in. It's basically like and this is something that with other database systems you will probably manage yourself, where you like generate an ID, or the database generates it every time, but you have to tell it to. I didn't tell it to create an ID, and it's probably better practice to have an ID generated by like you. Right. So sorry, for Calgary, the question was about this like ID generation here, and what happens if you already have like an underscore ID in the database. That's a good question. Like if you tried to insert, let's try to insert this object. I'm not entirely sure, but let's have a look. db.people.insert one. So we get back, I think it just picks it up. I think if it has an ID, it doesn't then account for creating a new one. Let's have a little Google of that. Because that's not something I've dived too much into. So object ID returns a new object ID value. wonder why it does it. So, but yeah, go for it. Yeah. Mm. So could you have two different IDs with the exact same data? Mm. Gotcha. Like, can you insert two IDs? It's a good question. I wonder if that actually created it or if it just found it as a duplicate. Yeah. Sorry, say that again? Give it a different name. Yeah. I'm actually wondering because I'm running .find and I'm only getting one back. I wonder if it's overridden everything. So if I do count, I get one. So actually by doing that, I think I've deleted the other objects. Peter, what have you made me do? No, I'm kidding. It's fine. We're definitely in NASA. Show collections. Maybe I wasn't in the right one. Find. Oh, okay. No, it was just because I think there we go. I was in test. So when I logged back into Mongo, I didn't use the use NASA. So therefore, that didn't really have an effect. So let's try that now by inserting the same one. It might replace it. It's certain. So like Postgres will complain. It'll go, no, you have something with that ID. Most databases would complain about that. I don't know how Mongo deals with that. Let's find out. There we go. Yeah, duplicate key error, and that's good. Like you don't want to be able to insert the same ID. So yeah, that's a really good question. What happens if you try to insert the same one? You should not be able to, and it will complain. Good on Calgary. Yeah, so that's a fun little exploration in. So now, like, db.people.find, and I'm not getting any like duplicate entries. It's just accounting for it. So, yeah, and you can put, so we've got find, we've also got delete. Actually, yeah, so now that I've entered in a new entry, I can go db.people.find. I can use this query filter. So I can go name, Sadie, and I get back this object. I can also, so we've looked at inserting, reading, we've done like a count. We can also delete. So if I go db.people, delete one, I can filter that as like the same that I did with find and go name, acknowledge true, delete count one. And actually, what I'll say about this is check these messages that you're getting back. I was playing around with this the other day and I was trying to delete something from the app itself and I was getting back a success message like, yeah, cool. But it wasn't actually deleting anything. It was just deleting 0. And it was because it was taking my filter and going like, no, I can't find anything. So it's not here. So yeah, it's all good. It's fine. So, you know, like pay attention to those logs because they can tell you things. So we've got the delete one, and you can put certain restrictions on this, like, oh, if you want to delete this thing, you can't until you've deleted this other thing. And that's looking a bit more into the stuff you'll be looking at next week. So you can do anything you want with this data. There we've got the data that we're going to be working with in an app. So that's a bit of a dive into the Mongo shell. We've seen how we can create the database, create the collections, insert into the collections, and then find and filter documents and delete documents. So when I say documents, I'm referring to these JSON objects. These are my documents. Calgary, how are you doing? Do you have any questions so far? You good? While I'm waiting for Calgary, Vancouver, how are you doing? Sorry, I didn't check in with you guys. You good? Any questions? You're good? Thanks, Christian. Okay, we're going to take a 15-minute break, and then when we come back, we'll look at how we do this in the node driver. So the Mongo, we're just gonna create like a tiny app kind of thing and implement Mongo into that app. Sound good? Cool. Thanks. Turn. Oh. Sorry. Woke me up. Do you use it for day one? The intro? Awesome. All right. Calgary, if you can give me a thumbs up or wave when you can hear and see me, that'd be fab. And I will actually plug my screen in so you can see that as well. Awesome. Thanks, Danny. And the stream's working okay? I'm just gonna mute you so I can cough. Okay, good to go. Calgary, we just did an experiment to use like a speaker in the room, and it was really bizarre, and I heard my voice like booming out of this speaker. So be thankful you don't have that, but we've decided not to go with it. So, okay, let's dive into a demo on how all of this works when we're inside the app. So we've seen how we can create a database, collections, and documents inside our Mongo shell, but that's not really serving us as of yet in terms of a web application. We want to be able to do all of that stuff, but inside our app. So we're gonna make just a tiny app-like app to show all of the people that are currently in space right now. And it's going to be it's going to look really familiar. I'm going to go through the setup of it, which is like our normal Express setup. And this should start to feel like, yeah, like I know how to set up an Express app. But I just want to go through this like right from the beginning to see how that gets implemented. So I've got my NASA folder, and I'm in it already. I've already got node modules. I've already done my have I done my npm init? I did do npm init, and then I was working on another branch, and then what I do is swap over to a branch and delete everything so I can start from scratch. So we'll see if this works. But we're gonna go touch app.js and npm install. I want to get Express, NodeMon, and EJS. Cool. And awesome. I've got my app, and yeah, it works. So I've got my package lock. So what I can do to run this is just run NodeMon app.js. We're going to require an Express. To start making our server, const app equals Express. Then we're gonna app.set our view engine. And what does this relate to? Templating, yeah, and in particular EJS. And then I'm also going to app.use express.static. And do you know what this does? It does, in a sense. What this does is say to use, it's like my assets that I want to use, and I'm going to have a public directory with my CSS in it. And that's what's going to like link it up. Because otherwise, if I'm running off localhost, even if I've linked to my, in an Express app, even if I've linked to my CSS and my HTML, it doesn't pick it up without this, which is basically just like a pointer going like, hey, no, you're at like this address that serves up the public assets. So this is going to look familiar to what we've used in like Tweeter, except we are using EJS for this, as opposed to like Ajax and jQuery. And let's add a listener. And we're going to have app. Don't listen. Listening on port 3000. So let's just test that works. Sweet, listening on port 3000. And now I've got NodeMon, so I should be able to just make changes as and when. We're going to create views for our index.html. And I'm going to hop in and just create our template really quick. I'm gonna kind of zoom through this a little bit because this should be kind of old news. People in space. Actually, we'll just call it NASA. And we're gonna have a H1 with people in space. And then an H2 with their names. And in order to render this on the page, I need a route, an app.get. We're going to go to people with our rec and res. And I can't forget the fat arrow function. I can just go index for that. Because I've got my template engine set to EJS, it knows to look in views for my index. Now what should happen is if I go to the right route, dun, 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 failed to look up view index in views directory. Awesome. That is because, does anyone know why that hasn't worked? Calgary, bonus points. The view part, the view engine, actually, let me double check that syntax. Yeah, that should be fine. The views is fine. It's something to do with the file that I've named. Calgary, any ideas? No. I've named it index.html. Was that what you were trying to say? Is it should be EJS? Or no? Okay, cool. Yeah, it's supposed to be EJS because I'm using EJS. And that should be why. Maybe we'll get another error. We'll see. There we go. People in space. Names. Awesome. Let's add a little tiny bit of CSS onto that because this is like front end week and I want to make it look a bit less garbage. So in order to do that, I'm going to make my public directory and index.css. Now, I'm just going to give it like background color. I wrote down this color when I was doing the app just because it was like really pretty, and it reminded me of space. And then when I was like just looking at my notes, I was like, don't ever write down like a hex code to have to type in when you're doing a demo. That's a bad idea. Just do, and I'm going to do that with color now as well. So we get D5, DB, E1. And then I'm just going to center it all by using Flexbox. So I'm going to go display flex. Have you played around with Flexbox yet? Not in this course, school. I don't, sometimes it comes up in the advanced lectures, and it's definitely worth like practicing once you're out of boot camp because it's a really powerful, I mean, CSS grid is on top of that, but Flexbox is pretty sweet. This is a nice quick way to just like align everything center. Right, so I have to link it in, and I can do that with, so in my index, link rel equals style sheet, and the href is going to be my index.css. And I'm going to close the tag like a good developer. Cool. And so you notice that this is actually, like this index CSS is not actually in the views folder. It's in the public folder, but because of this line, it doesn't matter. It just knows that that's where I'm getting my assets from. So I have people in space and names. And okay, now we want to actually get some data on the page. We've got like, this is our base. Let's put some data on the page. In order to do that, I need to install the Node.js driver for Mongo. And so I go npm install MongoDB at 2.2. I believe this is the same version that you'll be working with. When you're working with the Mongo shell, it's like 3.2, I think, and that should be the same as what you've got on Vagrant. So before we dive into this, before we actually connect it to the app, I just want to make a JS file and have a little script so that I can test out my connection to the database. So we're going to look at this, but kind of think of it as separate from the app for now. I'm going to go Mongo NASA.js, and let's consult the docs. So we have the Node.js driver documentation, and this is where I'm getting the information for connecting to my app. I have the installation guide, which is fine. I've done that, so I don't need to worry about that. If we head on over to Quick Start, got the npm install, start a Mongo server. Oh, hey, look, connect to MongoDB. And this essentially is the code that we're going to use in our app to connect to the database. So we are going to amend this a little bit. So it's going to look more similar to what you've actually got in Tweeter. So if we head on over to our Mongo NASA, I'm going to use strict and go const Mongo client. We're going to require it in .mongo client. And then we need the check in with Calgary. Oh, Griggly, you got it right. I'm sorry. And Britta, yes, points for Calgary. Sorry, I missed your answers. Right, so we need the like location that we're getting the database from, right? So we've got I write this in capitals, and this is something like it seems to just be kind of convention for things like API keys and like URLs to localhost is to name the variable as in capitals. I'm not entirely sure why that is, but it just is kind of a convention. Okay. Okay, so for Calgary in Python, is it? Like the convention is to put any constants in capitals. Okay. that would make sense. Yeah, because this is not like a changing thing. That's cool. Maybe it's inherited from that. So we got MongoDB. So this is our address. Oh, sure. Thanks, Kate. And let me get rid of the preview. Is that better? Awesome. Thank you. Okay, so our address, MongoDB, and we've got localhost, and it's going to look a little bit different. And then /, and this is where we put the name of our database. So this is what your address will look like in Tweeter, but we're going to then go /, and the database we've got is NASA. Then we're going to actually open up the connection. So we're going to say Mongo client .connect, and we're going to pass in the MongoDB URI, and then we have our callback, which gets in the database. Is that all right? Yeah, that's cool. We're going to account for the error, so we're just going to do a little bit of error handling. So if there is an error, then I just want to console log failed to connect. And then I'm just going to pass in I'll do it in backtick so I can pass in the address of the database, just so I can see that printed out. Have you had your errors and promises lecture yet? Not yet. I'll let them explain why error handling is important, but we want to account for this error because if I have several different errors in my app and I don't account for them, then I don't know which one it is, and I can't then narrow it down and fix that problem. So this is, we want to do good error handling. And we're just going to say throw error. Failed to connect. Okay, and then so assuming that this has been successful, we're going to console.log connected to MongoDB. And I'm just going to do the same thing where I've got the URI. And last of all, I want to close the database connection. Okay, so let's test that we're connected. And instead of doing anything with my app, this is just kind of, think of it as an independent script. I can run node mongo nasa.js. Okay, I'm connected. Awesome. And what this means is that now I can start writing queries to interact with the data that I have inside my Mongo NASA database. Sorry, I said database inside my water bottle. So sorry, Calgary, if that sounded weird. We're connected to the database, and now we can find the people in space. So what I'm going to do is add in here db.collection. So this should look familiar. This is the query that we've already run from our shell. And inside we've got people, which is our collection name. So this is how we would state the connection name in the Mongo driver. And we've still got .find. And we're going to pass it in just we want anything. So I'm not filtering the query. And again, we're going error and result. We hit the fat arrow. And again, if there's an error, I'm just going to throw error instead of writing a nice console log. And then result. Oh, sorry. Okay. I'm going to explain why I wrote this. It's not important, but I write in a language that's different to JavaScript, and the way that you print out variables to a screen is that you define them with %v, and then you do a comma and then the variable name. That is incorrect for JavaScript, so you can ignore that completely, because we just console log, and we can just say find result and pass it the result. And then we're doing db.close. Okay. And I'm going to put I should really connect, like say that I've connected before I actually try to make that call. And actually, I should move the db.close up into here. So now, okay, it worked. It's just that this is a whole lot of stuff that is kind of hard to read through. So when you're printing out just a straight up find, we want to add a little bit more parsing in, because it gives you like a whole bunch of information. It's just giving me like everything. And so in order to like kind of parse my data, I'm going to grab the people from this and just kind of like pop them into an array, or grab the objects or documents and pop them into an array. And so I'm going to change this to look like .find to array, and then I don't need this argument here, so it should just be error result, same kind of thing. Now when I run it, oh, like I could save it first, that would help. Run it again, and there we go. I've got a much nicer formatted list of my people array. So, the way that you're going to be doing this with Tweeter is slightly different. I'm going to show you an implementation where we're making this call in the routes, and you're going to have like your routes a lot more like nicely organized, and you're probably going to have these in functions that handle each one. So think of this as like a really basic implementation where we're straight up just doing it in the routes themselves. It's not like a best practice thing, but it's just I want to show you how this would look if you were just going like make the database call from this route and serve it up to the index HTML. So it's going to look slightly different from how you'll do it in Tweeter, but that's good. So we've got our script. Let's copy over some of our code into our app.js, because what I want to do really is be able to run this query inside my like get route. So I'm going to copy here. And now we're going to open up the database. So again, I'm going to copy this over. Connected, and we'll close it off. So I've got my connection string, which in theory, if I was then to run app nodemon app.js, cool. So I've got listening on port 3000, and I'm connected to my database, and this is good news. And I'm going to start off with making a database connection call to count how many people there are in space currently. So I'm actually just going to move my route inside the database call, because I want to be able to access the database within the route. And then within my route, I'm going to copy this .find to array. And what I'm going to do, before we get the people and the names, I'm just going to log the length, because I want to know how many people there are in space currently. And so I'm going to console.log what do we have? We've got result.length. Cool, and let's go to NodeMon. So now, when I head on over to people and refresh my app, I get 6. So I'm successfully connecting to the database, and I'm logging out the length of the result I get back in. I could print out, if I just did result, that would look similar to what we saw before, where I'm getting the full result. So we have this data. How do we render this on my HTML page? We could use our good old friend template vars. Just pop it into some template variables and send it to the EJS. We're using EJS, so that is something we can do. In order to do that, what I would do is store the template vars in here, or declare the template vars in here. Template vars equals, and I'm going to say number of people equals people.length. And then I'm going to move my res.render up here. I don't need a console log anymore, but what I do need to do is pass my template vars into the index template. So okay, so it errored. That's why I wanted to test that before we went on to the next part. People is not defined, which is why. You good? Results, yeah. So I went rogue and wrote people when I should have wrote results, basically. I just named it wrong. Let's try that again. Oh, I bet we got another error. Results is not defined. Okay, because it's result, not results. This is the fun part about being a developer. Why isn't this working? It's because I wrote the variable wrong. Okay, so it did an error, which is good. And now I want to actually like render that up on the page. So if we go over to my index EJS, people in space, let's say we're going to enter this in using our template. And we need an equal sign because we want it to render on the page. And then we can just reference the tag, the key of the object that we've passed in. The key in the object that we've passed in. So, ta-da! We're full stack developers now. It's done. See? We've got data from a database, and we're rendering up on the page. It's magic. Okay, now I want to send the people along, and I want to render them on the page. And so I would pass in people and just pass in result, basically. And now in my EJS, what I can do is write a for loop. So I'm going to go for, not 5, it's percentage. For var key in people. And then for every person, I want to add a new paragraph tag, which has people key dot name. And see if we render that up nicely. And then I just got to close the loop with that fun syntax. Calgry's good. Da, da, da. Okay, we have lists of names. This is good. This is what we want. Now, what if we want to add someone to the space station? What might we need to put on this page? A good old form. Yep. So let's add this in just under people in space. We're going to go H2 send someone to space. And form, the action is going to be to /people /new, because we're creating a new person. And then with the method post. And I want to have an input type text as per usual. And we'll take in the name of the person. We'll also take in the name of the craft so we can add that to the database as well. I'm just going to indent that a little bit. Whoop. A little bit nicer. And then last but not least, we need a submit button. With add. Okay. Excellent catch, Peter. Thank you. So for Calgary, I need to change the name of one of these because you're right. If I try to console log out rec.body.craft, it's going to give me the same. Well, it'll give me both fields. So this needs to be name instead of craft. And in quotes. Good spot. Okay, now I have my form. I'm also going to add in a placeholder so we know which one we're talking about. I'm going to go craft and name. There we go. We need body parser for this, so we're going to do an npm install of body parser in order to be able to parse the response coming in through from the form. And then in our app.js, we need to require it in. Body parser. And then we also need to say app.use body parser.url encoded. True. Okay, so now we're set up to be able to get that incoming request. And we need a new route. We need to make a post route for this. So when I post to people new, find where that finishes, we need app.post. And actually, it should just be a post to people, not people new. Because we're not, people new would be like if we were rendering a create new page, but we're just going to make the post to people. So we've got app.post people and rec and res. And then I'm going to create an object that we can pass into our database call. So we're just going to create new person equals, so name is one of our keys, and that's going to be rec.body.name. And then craft is the other. And also rec.body.craft. Okay. We have our object. We want to pass it in. We do this with another database call. And this is going to look familiar to this, but instead of here, instead of find and toArray, what do you think we're going to use? Insert. Yeah. We're going to use an insert query. And so db.collection people, and it's going to be insert one because we just have one thing that we want to insert. We're not inserting like an array of objects. We're just inserting one object. We pass in new person. We pass in the callback. And we get back an ID from this. So as we saw, like when we were logging, when we were doing this in the shell, when we insert, we get back an ID. So that's going to be stored in here. And then we're going to do a res.redirect just to people. And so hopefully then we can see the new person. Okay. So no errors yet, which is good. No errors yet. Who would like, we're going to do this. I do a cow tracking lecture, and I've still got the names of the cows, but I would feel bad sending a cow to space. So who wants to go to space? Can I have a volunteer? Devin, go to space. Thank you. What craft are you on? You want us to pick one? You can be at Lighthouse Labs. Calgary, I'm sending one of you to space as well, so prepare your answers. Awesome. Gregory wants to go. Okay, you're next up. What? We have 7 people in space. Devin's in space. Woo! Okay. I want to make sure I am spelling your name right. Gregory, what craft are you on? You really want to go? I know, we're sending you. It's so exciting. Sign up. Oh, this is going to be a long one. The suspense is building. I'm an excellent dishwasher. Awesome. I think they would be lucky to have you in space. Okay, we'll send you to the ISS then. You can be their dishwasher. There we go. You're in space. Right? And now, if I hop on over to my shell and I run my db.people.find, I get Devin and Gergely. And you are now in my database. And I own your data. So now we've successfully shown some data on the screen and added to it, which has then added it into the database. Now, if I stop my server, just kill it, I still have my data. Yay. We have just about enough time to quickly go through a delete, if that sounds good. We'll delete some of the people that are currently there. I'm going to leave Devin and Gergely in there, so don't worry. We're going to create a form. I'm going to get rid of this one in our EJS to be able to delete a person. And we're going to add that into our for loop so it renders a button for each one. We got form action. And my route's going to look nice and fun because I'm using EJS. I'm going to have the reference to people key.id. And then /delete. The method is post. Oh, I didn't create my closing tag. That's fine. And we're going to give it a button of type submit. And then have delete. And when I load it up, I should be able to head on over and see a delete button. Sorry, say that again. Excellent point. Thank you, Peter. I do need an equal sign in order for it to be the correct route, because otherwise it's just like thinking I want to like loop through it or something. The equals means that I actually get to see what's in there. Cool. But I do have a delete. And I also have like a little extra / that I don't need. Why are you in there? People, oh, because it's not getting the ID? Let's have another look. People key.id. /delete. Let's just try and grab the ID from here. You know why it is? This tripped me up. It's not ID, it's _ID, right? Cool, so now I'm gonna delete Oleg. Oh, come back. We needed a refresh. Cool. Okay, so now I've got the correct route. I just need to account for it in my server. And this is going to be another post. So we go app.post. And it's going to be to people ID delete with our rec and res. And then this is going to be my delete query. So instead of like insert one, it's going to be delete one. Actually, I'm going to use, we'll do delete one. DB, there's also remove, which I was playing around with a bit, but delete one is perfectly fine. Now here's where it gets fun. Because of this like object ID, just giving it this ID won't delete it. I don't think you're going to have to deal with this in Tweeter, so I'm going to gloss over it a little bit. But what I do need to do is store object ID and require the MongoDB dot object ID. Yeah. And then in my filter for what I want to, oh, sorry, I said I was going to use delete one and then I totally wrote remove. Delete one. In my filter, I state it as, so we've got _ID, and then object ID. And in here is where I put the rec.params.id. So this grabs the ID from my parameters that I've put in here, and sets it as this object ID, which will then allow me to delete it. And then, of course, we've got our function with error and results. And last but not least, I just want to res.redirect to people. And I'm going to put it in quotes properly. People new. Okay, so no errors. I'm still like always kind of surprised when I don't have an error. It's like a nice feeling. Okay. What happens? People new. So I've written, I don't have a people new route. I just want to redirect to people. But what happens if I refresh? Oleg's gone. We deleted him. What happens if I delete David? 6 people in space. Anne. Alexi. We can just go on a deleting spree. And now, same thing, if I like kill my server, I've only got 4 people in space. I know I went through that section like relatively quickly. Before we head off, any questions on any of this? Or any clarifications or anything you want me to kind of go over in a bit more detail? Calgary, how you doing? Sure, so the requires in the app.js, like this whole mess of code. Yes. So what we've got is, first thing we're doing is requiring Express. This allows us to be able to use Express in our app. And then we're like instantiating an instance of it. And this is like this app. This is the app that goes in front of like app.get, app.post. App.setViewEngine is what allows me to use EJS as the template. And so this is going to assume that I have a views folder and look for that in order to serve up my HTML. Which I have to name as an EJS file. Even though it's like syntactically, it's HTML apart from when we're importing those variables, but it's named as an EJS, the file extension. This express.static public allows me to, in a similar fashion, it knows I've got a public folder that has my like assets. And that's what allows me to write this without specifying like the rest of the path. Here, similarly to how we've required in Express, this is where we're requiring in the Mongo client. So when I npm install Mongo client, or like Mongo, this is what's requiring it in. The URL or the URI, which are the same thing, is the connection string, so the address that this app can find my database at on my computer. Yes, yeah, that's right. By default, it's that number, yeah. It should be the same with Tweeter as well. Yeah. So the question was just about localhost this number here, 27017. How do I know it's there? And that's by default. Thank you. Would you keep some kind of buffer between the user and the database, as in undo the delete action, or maybe keep a new database of delete items? That's a great question, Britta. And that's a really good like intuition on that. And yes, in ways that like we probably won't deal with in Tweeter, if I was making a call to a database and something along the way happened, maybe there was an error or like an undo, I would want a way to like not complete that database call. And there's different ways of doing that. Trying to think of how I use that. It would be using muxers maybe, which is kind of a word that I'm just throwing out. But you would set it up so that you could essentially roll back the transaction. So you're making a database call, something happens, or you want to undo it. And so what's happening is there is a buffer set in, whether it's, and that would have to do with how you're writing it and what you're using to write it, which then would just roll it back and not complete the database call. So like absolutely, it's just not something we really touch on with Tweeter in particular. But if you're like interested in database stuff, then it's definitely something that you would encounter when like making an app. What was that word? Muxers. Sorry? Committing the... Right. You're not committing it. Yeah.
But from a front-end application,
you would have to intervene from a front end. Yeah. That's a good point. Yeah. And so it would be in your back end code that you would have like an intervention point there. So Britta, I muttered muxer and then kind of regretted it because I think that might be making it more confusing. And now Joel's like looking at me. Muxer, deplexer. Yeah, it's muxer. You can have a look into it. Like I said, it's not super important right now, but worth thinking about, and that's a really good point. Anything else from anyone in Vancouver or Calgary before I go on? There's a lot more database stuff and things like that, and things that you will explore more in detail next week, aside from MongoDB. Awesome. So that's today. That's Mongo. Have fun with it. Calgary, I'll see you next week. If you have any questions, feel free to Slack me. Vancouver, I'm around all day, so you can just like shout at me. But have fun.